So students, welcome back. So yesterday we were looking at this problem, okay, and I mentioned the region of convergence in the context of Z transform. It's the same as that in the case of Laplace transform, only that in this case we'll have circular rings as region of convergences, okay. So the set of all Z's where the summation term converges, okay. So let me. Okay, so we saw this example, okay, where the power we saw that when we solve this problem here in this particular step, we saw that the Z transform is nothing but a power series expansion of the terms a power Z inverse, okay. So the first term is AZ inverse power 0, next term is AZ inverse power 1, AZ inverse power 2, so on and so forth, okay. So we saw that what happens when mod of AZ inverse is greater than 1, okay. So in that case what will happen is, so the series, the power series expansion will go on diverging, okay. So the sum goes to infinity, so I told you to take a specific example and solve it. So when you substitute in this case, so the power series obviously diverges, hence there will be no finite sum, okay. So we say that Z transform doesn't exist. So when mod Z is greater than mod A, what happens is A by Z, okay, will always be less than 1. A by Z whole square will be again less than A by Z, okay. So the cube will be less than the square as well as less than power 1, so on and so forth, okay. So the series will now converge, okay. Hence the set of all points where this power series does not go to infinity or it does not diverge is called as the region of convergence, okay. So we saw that it is the same exactly as in the case of Laplace transform, right? But in this case we have circular rings, okay. So the region of convergence doesn't depend on the value of omega, it depends only on the mod value of Z, okay. So that is on R, the length of the radius from the center or the origin, okay. And this plane here, right, so where I have marked blue shades, okay, so this is called as a Z plane, okay. And this circle with radius equal to 1 is the unit circle, okay. If the region of convergence includes this, the unit circle, then we say that the discrete time Fourier transform, which is the counterpart of discrete time counterpart of the continuous time Fourier transform, exists. If the region of convergence does not include this unit circle, then we say that the DTFT doesn't exist, okay. So it's the same as in the case of this one, the Laplace transform, okay. So moving ahead, so we'll see another example, okay. So the same thing that we did for Laplace, so we are going to do for Z, okay. We'll take another example and we'll see the significance of the region of convergence, okay. So okay, so we'll look at this, the Z transform of this sequence, right? Find x of Z, okay. So we see that x of Z by definition, okay, so have the habit of writing this. So when I substitute, since u of minus n minus 1 exists only from n equal to minus infinity to n equal to minus 1, so I'm going to use the same limits, and it is 0 for n greater than or equal to 0, right? So this will be minus infinity to minus 1, so minus sign outside. So I'm not going to write u of minus n minus 1 because the value is unity for all the values that are between these limits, minus infinity to minus 1, okay, z power minus 1, okay. So this I can write it as okay. Now what I'm going to do is so I'll take this I'm going to make the top limit 0. Okay, which means I'm adding the term a z inverse power 0, which is equal to 1. So I'm going to compensate it by subtracting it by minus 1. Okay, so okay, fine, I'll elaborate the step. Okay, so adding a 0 doesn't make any difference. Okay, so this I can write it as minus of bracket summation n going from minus infinity to 0 a z inverse. Okay, again it doesn't matter. So this is one of the okay, fine. So I am absorbing plus 1 inside the summation, and this is what I get. Okay, now if I expand this, so what I am going to get is minus of minus 1 will be equal to 1 minus summation of n going from minus infinity to 0, okay, a z inverse, okay, right, fine. So next, so this is my x of z. Okay, so now what I'm going to do is, so I'm going to make a substitution. Okay, let n equal to some minus k, which implies n going to minus infinity will make k go to infinity, and n going to 0 will make k going to 0. Okay, so and since addition is commutative, I can interchange the summation limits. It doesn't matter if you add 0 term first term second, or the other way around, that is a plus b equal to b plus a. Hence, so I'm going to incorporate this commutative law in this step. Summation k equal to 0 to infinity a z inverse power minus k. Okay, now so if you expand this, what you are going to get is 1 minus 1 plus a z inverse power minus 1 is nothing but a inverse z power k. So a inverse z plus a inverse z power 2 plus so on and so forth. Okay, so this if you write, so this will be 1 minus 1 divided by 1 minus a inverse z, 1 by 1 minus r. It's an infinite geometric progression or geometric series, right? So this will be the sum. So if you solve it, so what you are going to get is, okay, sorry, okay, so this is what you are going to get. So just simplify this, take the LCM and simplify, so you'll get this term. Okay, so the condition here is the mod of a inverse z has to be less than 1. Okay, so which means mod of a inverse z square will be again less than 1, so on and so forth. Okay, so what will the condition be? So x of z will be equal to 1 by 1 minus a z inverse, provided mod of z is less than mod of a. Okay, so here, right, so we see that the z transform here of a power n into u of n and the z transform of this which is minus of a power n u of minus n minus 1 is the same, except that these two exist, right, in different regions. Okay, so wherever this is existing, so the second one, the z transform of this doesn't exist, and wherever the z transform of this a power n u of minus n minus 1 exists, right, the other one doesn't exist. Okay, right, so if you draw the region of convergence on the z plane, right, so this is the unit circle. Okay, Now suppose say this is some A. Okay, now the region of convergence is this, mod z less than mod A. So what is mod z? It is set of all the radiuses, right? Set of all the circles which have radius less than this mod of A. Okay, so all these values, right? Whereas in the previous case the z transform was outside of this, in this case the z transform was inside of this, and the DTFT of this exists because this region of convergence includes the unit circle. Okay, fine. And next, so we'll stop here